function f of x only exists from 0 until L. It is not periodic. So in this case, you can expand the function to be an even function, okay, to be an even function, so that because it is the new function f1 of x is an even function, then in fact you have a Fourier cosine series, or we call this one as a cosine half-range expansion. Why? Because 0 until L, when you expand to be even, then the period become 2L. One cycle become 2L. Okay, so you just have, this is half range. So we expand another half range. So we call it cosine half range expansion. We can also, if you don't want to, if you think that, oh, if you do cosine half range expansion, you need to calculate A0, you need to calculate AN. You think that it is too much, too long, it takes time. Then you can expand as a sine half range expansion. In that case, oh, Nakarin, thank you. He will share the recording with the other students, okay? So I don't need to give you the PDF file. I go back to this one. So this one you expand as the odd periodic function with a period of 2L. So this is the original input. You expand as a odd periodic function, and you will get like this one. So comparing between cosine half-range expansion and sine half-range expansion, so you see that this one you just calculate one coefficient of the Fourier series, that is Bn. Okay, any questions up to this one? Any questions about this? No? After that, we also discuss about the complex Fourier series. Okay, so this is the Fourier series representation, the general formula, basically like this. So in case after we use the Euler theorem, remember we express cosine nx into the summation of complex exponential function. Okay, cosine nx is exponential inx plus exponential minus inx over 2. Okay, and sine nx you also express as the summation as the 2 exponential function. Then after the derivation, we got like this one. In general, you can express the function f of x into complex elementary function. The coefficient is now Cn, okay, and Cn is this one. This is the definition of Cn. So this is the one that we discussed, and we also define the relationship between Cn and the coefficient An or Bn, right? So last time we said that the amplitude spectrum is equal to An, correct? So we can also, from the complex Fourier series, this one is in fact An, right? Remember that one? An. You still remember, right? Last time we used for normal Fourier series, the amplitude spectrum we express as an. That is square root of an squared plus bn squared. Sorry, right. So now we have a coefficient Cn. Okay, so follow the previous example when we have a periodic square wave odd function. Okay, odd square wave function. Then you see that as last time our an is equal to 0. You have only bn. So now it means that C1 is equal to B1, C3 equal to B3, C5 equal to B5. Okay, so when we plot, you will get the same thing as the previous discussion. Remember this one, right? The one that I show you. I think the last discussion, last what is that? Last Monday. So this is a function amplitude spectrum as a function of n. Okay, n 1, 2, 3, 4, 5, and so on. Sometimes, if you read in literature, in the textbook, they don't say about amplitude spectrum. Okay, they say about power spectrum. Power spectrum. So it means that the amplitude square. So this is for the, if you see the scale, this one 4k over pi, this one becomes 16k squared over pi squared. Okay. In case of power spectrum, then you have Cn squared is equal to An squared plus Bn squared. Or in this example, okay, following this example, you have one C1 squared is equal to B1 squared, right? This one from here to here. From this one, C3, it becomes C3 squared. C5 becomes C5 squared. So I just kept, okay, roughly it's become like this one. Okay. Any questions about this one? No? Okay. Then another example, because I show you only coefficient Bn. So this is the example. Last time when the rectangular waveform is even function, then we got the result like this one. So remember that one, that you have A0 that is equal to k over 2, okay, and you will have An, right? Remember this one, right? So in this case, when you plot the amplitude spectrum as a function of n, coefficient number, so you have A0, so your A0 is k over 2. I plot where the maximum is k, so this is a k over 2, it means that A0 is 0.5. This one 2k over pi, okay, 2k over pi. So this is k is, if let's say k is 1, 2 pi is 3.14, 2 over 3 is about 0, more than 0.6. Okay, so you've got A1 here. After that, you have A3. Okay, this is A3. And you have A5 like this one. Okay. So similar to the previous discussion, then you can get the power spectrum. So now if you see, it is k square. Okay, from A0 amplitude, you have A0 square. From A1, it becomes A1 square. A3, it becomes A3 square, and so on. Okay, any questions up to this one? No? Okay, right? Okay, after this we will talk about non-periodic function. Okay, after this, the next discussion will be Fourier representation of non-periodic functions. And last Monday I told you already, I will let you to explain your homework number 2 about plotting the partial sum of the Fourier series. Remember? So I would like to listen to your explanation. I got your homework already, everybody. Okay, complete. So please tell me, say something about your homework. Homework number 2. Okay, homework number 2 that I let you to plot the sum, the plot of partial sum. Okay, so please, who want to, you can share your screen. Okay, you can share your screen. So who want to be the first? Who want to be the first? Please. Somebody.
I do.
Nakarin.
Cepat.
Nakarin want to present your homework number 2. Who want to be the first? Anybody okay? Nakarin or Papa Wit or Chitinan or Tiprat, who think that okay, I will explain my homework and then
I will be the first.
okay. Can you share your screen?
Yes.
Okay, Tiprat, right?
Yes.
Okay. Okay, Tiprat. I open my, yes, please.
Do you see my
No, not yet. Not yet.
wait a second.
You have to, yes, coming, it's coming. Okay.
Okay. Let me see the question. Yes, the question is to plot the S1 to S4 of the function that you gave us. The first I assume k is 1, and for the degree I start with 0 and I add it by 10 by 10, yes, like this, and I change it into the radian
Okay.
by this, yes. And for S1 I use I type like this in the function bar, formula bar. Yes.
Sine of C2. Okay.
And for S2 I use this
So sine of C2, column C2 plus 1 over 3 sine 3 times of C2. C2,
Yes.
okay, the angle,
And for S3, I use this.
Yes, okay.
Yes, and the last is C4.
Mm,
Right.
mm, mm. Mm-hmm.
And I drag the like this, and it become, and I use 1,000 degree of the
1000 degree.
yes,
So what
and
happens
it's
if you so now the horizontal axis in degree, right? Mm-hmm. Mm, mm. Okay.
yeah,
So you
and this
got
is the
S1.
result.
S2 is like that one. S3,
Yes,
S4. Mm-hmm. So you answer when when more terms are included.
yes. It will be the straight line like this.
What do you
Uh,
a straight line?
yes.
What
Is
what do you mean? Why you think that it will become a straight line? You test already?
yes. I test it, and I see the graph that you show us that is a is a the amplitude is will be the constant.
Mm-hmm. Amplitude will be constant. Mm-hmm.
It will equal to 1 or k that I assume.
So it means that the amplitude last time, I mean, when let's say it is when you compare S4 and S3, so the amplitude fluctuation, okay, that on top, the amplitude in fact fluctuate, right?
Yes, yes,
You understand, okay, when I say fluctuate. So it means that the fluctuation reduce, you mean like that?
yes,
Reduce to one, right? Reduce to be a constant.
yes,
Mm-hmm. Mm-hmm. Okay.
yes.
So you use okay. I see. I see. Uh-huh. You say that you when you say that it will become like a constant like this one. You try by yourself, or you just because I draw like that one.
Yes, and I see the trend of the graph.
Mm-hmm.
Yes, it should become like that you show us.
Mm. But you didn't try. Let's
Yes.
say you try with S5 or X6 like that. No,
No,
you
no, no.
didn't try.
That's
Uh,
yeah.
uh-huh, uh-huh. Okay, okay. Thank you very much, Ifran.
Yes.
Good.
Thank you.
So the next one.
All right.
Oh,
Next one should be me for Pavit.
Oh, okay, Papa Wait. How about yours? Can you say something about your homework?
Can you see my
Not yet.
Excel?
Not yet, Papa Wait. Not yet. Not yet. Come.
Can you see
Okay.